Here are 15 Puerto Rico Medical Board-style clinical vignettes focused on biostatistics and epidemiology, covering sensitivity, specificity, PPV, MPV, and clinical trials, with 4 answer choices and explanations. Biostatistics and epidemiology, sensitivity and specificity. 1. Sensitivity calculation. A new rapid COVID-19 test correctly identifies 95 out of 100 infected patients, but also incorrectly classifies 10 uninfected people as positive. What is the sensitivity of the test? A, 85%, B, 90%, C, 95%, D, 99%. Answer C, 95%. Explanation: sensitivity equals true positives plus false negatives. Here, 95 plus 5 equals 95%. Answer 2, specificity calculation. A mammogram correctly identifies 980 out of 1,000 women without breast cancer, but misses 20 cases. What is the specificity? B, 95%, C, 98%, D, 99%. Answer C, 98%. Explanation: specificity equal true negatives plus false positives. Here, 980 plus 20 equal 98%. Have 3. Effect of sensitivity and specificity on screening. A highly sensitive test is most useful when the goal is to A, confirm a diagnosis, B, rule out a disease, C, reduce false positives, D, replace more expensive tests. Answer B, rule out a disease. Explanation: a test with high sensitivity sent out minimizes false negatives, making it ideal for ruling out disease. Positive and negative predictive values, PPV and MPV. 4. PPV and prevalence. A disease has a prevalence of 1 cent, and a test has a sensitivity of 90% and specificity of 95%. How will the PPV be affected? A, low due to low prevalence. B, high due to high specificity. C, unchanged because PPV is test dependent. D, equal to sensitivity. Answer, low due to low prevalence. Explanation: PPV depends on prevalence. Even with a good test, a low disease prevalence lowers the chance that a positive result is a true positive. NPV and prevalence. If the prevalence of a disease decreases, what happens to the NPV? A, decreases. B, increases. C, remains the same. D, becomes equal to specificity. Answer B. Explanation: with low prevalence, the probability of being disease-free increases, raising NPV. Likelihood ratios, letter 6. Positive likelihood ratio, LR-MINE. A test has 90% sensitivity and 80% specificity. What is the positive likelihood ratio, LRS? A, 1.0, B, 2.0, C, 4.5, D, 9.0. Answer C, 4.5. Explanation: LR-MI equals sensitivity, 1 minus specificity equals 0.90, 1 minus 0.80 equals 4.5. 7. Interpretation of LRI. Which LRI value provides strong diagnostic evidence for a disease? A, 1.0, 2.0, C, 5.5. Answer C. Explanation: an LR-5 significantly increases the probability of disease. Clinical trials and study designs. 8. Randomization in clinical trials. What is the primary advantage of randomized controlled trials, RCTs? A, eliminates bias. B, ensures equal follow-up in groups. C, balances confounding variables. D, provides real-world evidence. Answer C, balances confounding variables. Explanation: randomization ensures groups are comparable, minimizing confounding. 9. Intention to treat analysis. In a drug trial, some patients drop out due to side effects. The researchers analyze all participants as per original assignment. What is this approach called? A, per protocol analysis. B, intention to treat analysis. C, cross-observational study. Answer B, intention to treat analysis. Explanation: this preserves randomization and prevents bias. 10. Types of bias in clinical trials. A study on a new hypertension drug excludes elderly patients. What type of bias is this? A, selection bias. B, recall bias. C, observer bias. D, lead time bias. Answer A, selection bias. Excluding certain populations affects generalizability, introducing selection bias. Statistical interpretation. P-values and significance. A clinical trial finds a p-value of 0.03 for a new cholesterol-lowering drug. What does this mean? A, the result is due to chance. B, the drug is clinically superior. C, there is a 3% probability the result is due to chance. D, the drug is ineffective. Answer C, there is a 3% probability the result is due to chance. Explanation: a p-value 0.05 suggests statistical significance. Hack 12. Type 1 versus Type 2 errors. A new antibiotic falsely appears effective in a trial. This is an example of A. Type 1 error, false positive. B. Type 2 error, false negative. C. Selection bias. D. Recall bias. Answer: A. Type 1 error. Explanation: type 1 error occurs when a false positive result is mistakenly considered significant. Epidemiology and public health. 13. Relative risk versus odds ratio. A cohort study finds smokers have a 3 times higher risk of lung cancer than non-smokers. What statistical measure is used? A. Relative risk, RR. B. Odds ratio, OR. C. Absolute risk reduction, ARR. D. Hazard ratio. Answer: A. Relative risk. Explanation: cohort studies use RR, while case control studies use OR. And 14. Number needed to treat NNT. A medication reduces stroke risk from 10% to 5%. What is the number needed to treat NNT? A. 5, B. 10, C. 20, D. 50. Answer: B. Explanation: NNT equals 1 via absolute risk reduction equals 1. Weak point 0.19 plus 105. Hash I-15. Lead time bias in screening. A new prostate cancer screening test detects cancer earlier but does not improve survival. What bias is present? A. Lead time bias. B. Survivorship bias. C. Confounding bias. Recall bias. Answer: A. Explanation: early detection without survival benefit falsely improves prognosis. Would you like more practice questions?